Welcome, developers. Well, the happiest wishes for 2026, and I hope it'll be a good year for you all. It's been a while, and that all because of that small remark at the end. Next time we'll go back to C++. So this time, and let's have a talk about C++ because, well, something happened on the way to here. It all started some way back on GitHub. There is a channel that I'm looking at regularly. It's called C++ Weekly, and it's done by somebody called Jason Turner. He uses the handle Lefticus on especially GitHub. You can find him there. And he does a lot on spreading knowledge about how to use C++ and how to use the new features of C++. And he has a very interesting way of doing that because he quite often makes use of a live compiler that you can use, showing what the code does, how it runs, and also why it is as optimal as it looks. He promotes using automated multi-platform targeted builds with testing and a lot of different tests. And on GitHub, he has a CMake template generator. You can make a copy of that and start your own GitHub repository based on it, and it'll ask you a few questions, and then it will build a customized version of that template for you. Now, I like what he does, but of course, we're talking about Microsoft Flight Simulator, and Microsoft Flight Simulator is not multi-platform, it's Windows only. And not just that, it requires you to use SimConnect, which is a Windows-only library, which is only available in C++. And yeah, it's not using CMake. It requires Visual Studio 2022. So there is no real multi-platform escape yet for this, unless you do it yourself. And you can probably do that if you're targeting WASM, because you can use Clang for that. But it will get you into trouble. And then, of course, if you want to say, well, let's just start completely new, you would want to connect to Flight Simulator using the SimConnect network protocol, and that has never been open sourced or even documented publicly by Microsoft. So there are some reverse engineered libraries, even in Java, if you want, but there is absolutely no guarantee it keeps working. And when they make API breaking changes, then, well, you will have to try and reverse engineer whatever they changed. So way back in 2023, in January 2023, actually, I posted an issue on GitHub, which is the way that he allows you to put in requests or questions for the C++ Weekly series. And I put in there this message saying, so I'd like to do things the way you do it, but what can I do if I definitely am Windows only? And actually, I have a library that is Visual Studio only. So I put the question in there, and I said, this might be an interesting subject for a C++ Weekly installment, but yeah, let me know. And I got a response. I mean, it was 2025 in August, but actually it turned out he was pretty interested in it because he was already planning to do a public talk about the subject of how do you tackle a single platform situation, but still want to have the advantages of using multi-platform builds. And then I'm not talking about multi-platform in the sense of targeting macOS or Linux. I'm talking about using different compiler setups and different compiler environments. But of course, although I'm very happy that he was happy with it, he had a number of suggestions that were not entirely easy to take. So he started with port your build system to CMake. This was something I have been looking at for a long time, but yeah, CMake is an acquired taste, so that was not something easy to do. Of course, he said, make sure you have the latest version of Visual Studio. And we now have a Visual Studio 2026, but that's not yet supported by Asobo and Microsoft. So we're still on 2022, but nevertheless. And then start turning off compatibility flags. So try not to use the really Windows-specific things. As you may know, if you use Visual Studio in its default settings, it will allow quite a lot of stuff that is not standard. They said there is an option permissive that you can disable, and then it's going for the strict rules. Then continue with if you rely on external libraries that rely on Microsoft extensions, pull that code into a separate static library. Well, that is what we have. We have SimConnect, and SimConnect is in a static library, but of course we have a header file which still contains quite a lot of Microsoft-specific stuff. So we need to do something about that. I wasn't too enthusiastic about immediately going for a second static library before the C++ library, but we can do it in layers. Hopefully you now have more code that is portable. And then the next step, of course, is start going the other way. Make sure that everything that you have, your classes and your functions, are no longer using anything that is Windows specific. And at the moment, or at least at that moment, my C++ library was still using a lot of D words and SimConnect underscore something types and values. So that was still a far way out. Then taking those classes and functions, move them to their own library, which is, of course, this separation, and we can do that with 2 layers. And now add Linux or GCC or Clang builds that compiles just the portable components. Now, of course, doing it on Linux would be possible if I really make it into 2 separate libraries, but then I would need to make sure that I pull out all the Windows-specific headers and make sure that they are available intermediate and don't bleed over into this separate library. I still think we can do that pretty well with a layered approach. So let's call that a challenge. And that's what I thought I'd pick up to start with. But it turned to have a bit of an impact. So why did I really do this? Well, Visual Studio and its compiler are good, but they're very forgiving. If you use something like Clang, and especially a second tool that is coming with it, Clang-tidy, it will find a lot of potential bugs. It is very, very thorough in doing its analysis of your code, and not just for bugs and dangerous code and undefined behavior, but also a lot of rules concerning what you call good practice. If you've read the standard information about C++, you know that there is a special site also on GitHub where you can get all the good practice rules that you are advised to adhere to. Then being able to write and build using Visual Studio Code, which kind of requires you to go to CMake, was tempting. And of course, there is another tool that you could start using. If you have a CMake-based build, you can also use CLion, because CLion is also only accepting CMake. It's a bit stricter than VS Code. With VS Code, you could actually even do a VS build or MS build based builds. CLion cannot do that. So if you like CLion, and CLion is also a very nice tool, then you definitely need to go to CMake. Then, of course, there is isolating SimConnect behind a clean and non-Windows layer removes a lot of the ugly C++ 98 era stuff from the headers and the library and your own code. You don't need to use things like windows.h. And if you have looked at my examples, you know that they won't survive level 4 warnings. This is not something actually that is caused by SimConnect.h. SimConnect.h would have a lot of warnings that turn into errors, but the really difficult stuff is actually in the Windows headers. And they definitely are unfixable because, I mean, we're targeting Windows. So starting to do that kind of pulled the lid off, well, may I call it a cesspit? It opened up quite a lot of problems. I started out, of course, by just cloning the CMake template and then copy that over. And to my pleasant surprise, VS Code immediately starting to build. And of course, fail, because there was so much in there that wasn't acceptable. But still, from a modern software development practice perspective, I would say success. This is pretty much like what you do if you use test-driven development or behavior-driven development. You first specify what you want to get, and you do that by writing behavior tests, which are a somewhat higher level than unit tests. And then, of course, initially they will fail because you haven't built anything yet. But you do have, hopefully, a very good specification of the goal you want to reach. So let's start with our first goal, which is to get the build to run. And we're just going to use minimal changes. We're initially not going to make all warnings errors, but we first want to make sure that the build actually produces executables, and then start adjusting things and start to remove the ignored warnings so they become errors again, because you know that was the default that I was already using. And then we have to go for the root causes of those complaints. So adjust the coding style to C++ best practices. And yes, I'll admit my code was not up to that standard yet, because simply I wanted to have a quick result and just accepted that some stuff was not as good as it could be. But now we have a very good reason of wanting to fix that, because the build will fail really, really annoyingly. And then, of course, pull similar issues to a single location and use that as a reason for creating that extra layer. So we can have that layer do things that we want to avoid and expose that as a good code version. If we do that right, it won't even cost any extra performance. It just isolates the bad stuff into a single location and puts a nice layer on top of it. But yeah, there was a lot. But I mean, basically, there was nothing I couldn't agree with. And then, of course, the first thing that you have to get through is getting used to Clang-tidy, because Clang-tidy goes into a lot of itty-bitty details in what it wants you to change. Generally, most of those rules forced me to hide SimConnect completely, because it was saying if you use an definition value, so for example, any of the enumerations or values from those enumerations that are defined in SimConnect.h, then you have to directly include that header, which is a maintainability aspect. You want to make sure that everything you use is explicitly mentioned at the top of your file. But of course, that would mean that I would have to pull in all those dirty details that I was trying to get rid of. So we had to go to that layer. And this is, of course, what Jason suggested. He suggested it with explicit static libraries. I'm just going to do it with a layer. Now, it helped me hide actually most of those defined constants. There are still a number of them around, but if I do it right, they are all in a single place. #define is a bit of a strange thing. It is a preprocessor thing and can cause very weird bugs. In modern C and C++, you don't use them for defining constant values. Instead, you use const_expr for values, and for functions, you try to use const_eval. Const_eval means it is a constant value that needs to be evaluated. Of course, that is only possible if the compiler can really do that. Const_expr is almost the same, but const_expr says do it in the compiler if you can, otherwise generate the code and do the call at runtime. Const_eval simply says this has to be done at compile time. So it's guaranteed to be a lot more efficient, and it's also guaranteed to get rid of the code that you have in there, but it needs to be constant. There's a very nice presentation by Jason that you can find on YouTube. Just search for CPPCon 2017, const_expr, all the things. And of course, as that goes, there will be also some other presentations by people responding to that, because it is something that is also an acquired habit. You have to train yourself to do certain things in a certain way, and it doesn't always work out that you will then do the things the way you want them to do. There's nothing wrong with that, because one of the basic tenets you will learn when you work in IT is it depends. It always depends. But if you don't make sure that you actually ask yourself that question, can I do that here? Is it reasonable? And does it bring me enough value? If you skip that and just go immediately for let's just ignore it because it's too much trouble, or let's do it anyway, even though it doesn't give me the most optimal solution, then you're not doing your job right. Once you get started, you will find that quickly those fixes become predictable. And of course, I cheated. I used GitHub Copilot a lot, It saved me time as long as it was very well predictable. I used Claude as the reasoning agent rather than ChatGPT. Claude is a lot better capable of using this, which is why there is so much to be found about Claude code. Unfortunately, last time I checked, Claude code is not yet runnable on Windows. And if you want to run that on Linux, for example, using the Windows subsystem for Linux, then that should be possible. But it is a lot of work to get right. And then your next problem is that you need to have a build that will work from a Windows subsystem for Linux. And without CMake, that is a lot more work. So actually, maybe because of this and getting everything to work on a CMake, eventually we'll get the situation where we can use tools like Claude Code. Anyway, I don't know if you use Copilot or something like that. You will find it works most of the time as long as it is really doing stuff that is pretty predictable, and that is just simply a matter of saving you time because it's doing X times the same. If you don't do it that way and ask it to do something completely new, well, sometimes it comes up with great ideas. Sometimes, and unfortunately for me, that was most of the time, it does stuff and then you say, no, let's just undo that and I'll do it by hand. And in total, it will make you make that evaluation beforehand because you want to prevent to have it spend a lot of time on something that you then are not going to use. So do I still use Visual Studio? And of course, I still do use it because as a compiler, it does it a lot faster. The first reason for that is because it doesn't use Clang-tidy, and Clang-tidy has a lot of analysis to do, and it is not so quick. But executables also seem to be smaller. I'm not yet sure if that is because Clang by default still includes debug info on Linux with the GCC compiler and also with Clang. It is quite possible to just let the compiler include debug info even if you're doing a release build. And you can still debug that. That will work. It will look weird in the way it sometimes jumps through your code, but it is possible. And there might be some tunings in Clang that I haven't figured out yet because I'm just learning to use it. But for me, the most important thing is debugging, even though there is the possibility to do that. As far as I know, VS Code is not able to use the Visual Studio debugger. You can do profiling, but you cannot do the single-step debugging and running through your code. And that is sometimes a lot more, actually, for a lot of runs, a lot more productive than just adding a lot of logging messages and see what happens. CMake, yeah, it works, but it works because I just leave it alone as much as possible. It's an acquired taste. Customizing the build is pretty easy because the language reads and edits a lot easier than the XML files from Visual Studio. Yeah, you still need to learn quite a lot before you know what's happening, and there is a lot there that you simply don't know what's happening. It's magic. It works, but yeah, magic is great as long as it works. And if it doesn't, you have a problem because you don't have any idea of where things are going wrong. And then, of course, I just couldn't leave stuff alone. And I was kind of looking at Microsoft 2020 because there are still a lot of people targeting that and working with it. And there is a lot there that doesn't work. You cannot just compile with the 2024 SDK and expect everything to work flawlessly on 2020 because there are breaking changes, which means you actually have to make separate builds for targeting 2020 and 2024 unless you do some very smart stuff in your code, which actually implies that you're not using everything that's in the SDK and have duplicated stuff from there for yourself. SimConnect.h doesn't tell you which version you're compiling against. I put out an issue on the support page for that, but it doesn't look like it's something they're going to solve. And it's not that it's their fault because I checked for Lockheed Prepared and even the old FSX SDKs, and they don't do anything like that there also. However, it is possible to find out through other means. For example, Prepared, when they switched to 64-bit, and yes, that was a thing at that time, they introduced a hashtag-defined type called keyword. We already have dword, and it's used a lot. Some calls in the API are duplicated. You know that in MSFS 2024, there are some _ex1s. Prepared also made some special versions, and they were for the situations where they explicitly wanted to allow 64-bit values to be passed instead of 32-bit values. And then Flight Simulator X, it had a number of things already in use, but it didn't try to hide some C++ keywords as the current MSFS headers are doing. So there was no SimConnect _ref struct, and luckily that's a hashtag defined, so we can detect that. And then if you want to know the difference between 2020 and 2024, again, a new keyword was hidden using typedef, SimConnect _typedef. So, hashtag define. I'm not a fan. I want to stay away from it as much as possible. And there is a very important reason for it, because it's, strictly speaking, not part of the C++ language. Really. It works before the compiler even gets to see the code. This is why you have two different stages, or at least two different stages when you're compiling. First, the preprocessor, which takes all those hashtag things and changes it into something that the compiler actually does recognize. And that is why you can use it to hide words and even keywords. So you could do something like defining begin, else, end, if, and then do something like writing Pascal or something that pretty similarly looks like Pascal, even though you're still in a C or C++ environment. I mean, that's just a small joke, but it is something that is actually possible and unfortunately very close to what is happening in the SimConnect.h file, because it is replacing certain keywords or combinations of keywords with hashtag define things. You can use it for a constant, and you can even use it for expressions. This is something that is done and has been done quite a lot, because you can use a hashtag define with parameters and then do an expression, but it can get you into trouble if you're not careful. For example, if you write hashtag define 2 as 1 plus 1, then you use that to do things with it, you will get strange results because plus has a lower priority than multiplication. And that means in this case that 4 is printed as 3. This is just a simple example, and most modern headers that use hashtag define will be very careful and use copious amounts of parentheses to prevent this. There's a very good thing you can do to prevent it even further, which is to use const.expr and const.eval and just get rid of these things. So if you want to use it at most to hide parts of your code from the compiler that you need to hide. A typical example is to use something like ifdef and debug, for example, to make sure that you have certain debugging code that only exists when you're debugging or doing a debug build, but is not there in a release build. Actually, with const.eval, there are some ways you can get that done even without using hashtag define and ifdef. But anyway, in our case, we're going to use that to hide pieces of the 2024 API that the 2022 SDK doesn't know about. So even though we're going to get rid of it, there are also things like pure enums. In C and C++, and yes, enums do exist in C, there is an enum and an enum class. If you just say enum, then actually the values that are a part of that enumeration are defined as global constant values. However, even though they are quite often written with all capitals, they are really not the same as hashtag define. This is something you have to be careful about because it looks that way, but it isn't. So you cannot check whether or not a member in an enumeration is defined because it isn't. It's not hashtag define. Instead of enum, you should always use enum class, and then those values are inside the scope of the enumeration. This, of course, means that you have to use type name : value name, but hey, in the current header files, we have SimConnect _ in front of every defined value. So we're prefixing it already. And if it's, for example, a sim object type, it's SimConnect _ sim object type _ something. So we're in effect already doing that. So there's no reason not to do it the right way. Take a look. If you go and take a look, by the way, in the examples of the SDK, you will find that they're using these old school enumerations to define values. Yeah, I think they should be enum class. There's no reason not to do that. By the way, something I found out when I moved the build to Clang is that actually these things, which are in all the examples in the SimConnect SDK sample code, this is actually invalid C++. Static enum is only allowed by Visual Studio because it is the beginning of defining a variable. The idea is that the enum type is then only used for that particular variable and not for others, which is usually not what you want. But Visual Studio accepts static enum without the variable name, even though this is not allowed. So you shouldn't do that. So how's progress? And let's go and have a look at a bit of an overview of the calls that we have in the SimConnect API, because we can immediately also take a look at what we have been doing over the past in the YouTube series. So there are a number of general calls: open, close, call dispatch, get next dispatch, and get last sent packet ID. These we've dealt with, so we've looked at them and discussed them. We've not yet discussed flight load, flight load, flight save, and flight plan load. We've looked at system state and system events. We've used subscribe to system event, unsubscribe, and request system state. But there are also some new calls in 2024 that we haven't discussed yet. Set system event state and set system state, and also flow events, which are a different kind of system state event or system event that have to do with your flow through the UI or the flow or what the user is doing in Flight Simulator. We've looked at sending and receiving data with the data definitions and requesting data. We haven't discussed clear data definition, which is a pretty obvious something, and we haven't looked at client data yet. And then, of course, AI sim objects. We've discussed all the calls, but only used the create non-ATC aircraft. Facilities, we discussed them a bit, but I do have a cool demo now. So let's do that. So we have a bit of a demo. Okay, let's do it like this. Let's see if everything will work. I'm showing here example 9.2, which is list liveries. And this is a small demo to show a list of all the available titles and liveries. You'll see that I'm slowly trying to move all the C++ examples so they start like this. Just make an alias for the connection and the connection handler. And in this case, we're using the SimObject and livery handler. And of course have an alias for that also. Then all of them will use this version function to create a nicely printable version of a version, which is used by handle open. And then we have handle close, and we have handle exception. And I just collapse them like this. And for example, if you look in handle exception, then you will notice that I am using this type, messages : exception MSG, and that is an alias which is defined in the SimConnect /SimConnect HPP header. This way, I'm hiding the actual message type in that header, and we won't be using the all capitals SimConnect _RECV exception and those types of message types and hide those. If we would use it here, then immediately Clang-tidy would force us to make sure that we have the header. SimConnect.h as well, and that's something we want to avoid. This way it works quite nicely, and it looks pretty good and not too difficult. If we go if we go down here, you see that the actual message IDs also have their own values. Still looking, currently what I do is I create a namespace instead of a new enumeration. I probably could use an enumeration as well. Not sure which one is the best, but for the time being, this works quite well. And this way I've got everything hidden in that header file. Then we have gather args. That has been used before already. It uses the argc const char pointer argv array. And of course, Clang-tidy doesn't like that. So we need to tell it to don't bother with that. We're not going to change that simply because it is the way the arguments are passed. There are no std arrays used here for it. And actually, for the application name, we could use a string view. Maybe I'll change that, which is the nice way to do it. So for this example, we gather those arguments and then check for a positional argument, argument 1, that we can use to say what kind of titles and liveries we want listed. And that works like this. And you see here, there's only this if MSFS 2024 SDK. And that is the way I'm checking whether or not this is compiled against the 2024 SDK rather than the 2020 SDK. So we'll collapse that. Then I'm using an argument debug. So you have to use --debug for that. And if that is specified, then we're going to set the log level to debug. And otherwise, the log level is info. Going down, we set up the connection, set the level for the connection handler, set the log level for that. Then we register the handlers for open, quit, and exception. And then we declare this object and livery handler. Then we set the logging level on that one as well. We request the enumeration, and what we do is we use the version that gathers all the arguments into a map, and it will be a map of string to a set of string. The idea is you get one key that is the title, and then the value is a set of liveries belonging to that title. Of course, if you're compiling against 2020, there won't be liveries. So you will always have one entry in the set, and that is an empty string. When we get the map, we just go through it and print out the result. We use a Boolean listing done to mark that we've finished with our listing work. And then for the connection handler, we use this new method, handle until or timeout. And this is a very simple one that allows you to provide a Boolean returning method. And it will test every few milliseconds or after every message has been received, whether or not the timeout that you can pass has been reached, or else the listing is done in this case, which is that Boolean variable that we're setting. And because we're using it in the Lambda, we have to capture it here. And here you see the timeout set to 30 seconds, and we're using that chronoliteral suffix that you can use to make this a chrono milliseconds or chronoseconds value. So if we're done, we stop the request explicitly, which just deregisters the handler that we registered here, and then we close the connection. So that's a very simple application, and I can run it now, but you'll believe me that it will do exactly the same. However, the interesting thing is that bit about supporting 2020. Now, if we go and look at our, no, let's not do it like this. We open the library include directory. And we go in here to the SimObject and livery handler that we just used. Let me close this one. And now you see here that if we do not use 2024, it is going to use a scanner. This is a scanner that I discussed a way back. And what it actually does is that it will go and look at the stored files, and it will look actually at all the add-ons registered for aircraft and other sim objects. It will collect all of them, check if there are any aircraft or other sim objects declared in there, and then return that, which is then used by this handler to return our content. So here, in this case, you see that the actual registering of a handler and using the connection to call the enumerate sim objects and liveries there is being ignored. Instead, we instantiate the scanner and then let the scanner run and use that same handler. If we use the call with the map, like we've been doing in this demo, then it works just the same way. But now it will first create the map. And due to some copy and move semantics for the Lambda, I create it on the heap and then fill it. So this is something that I've been doing, one of the things that I've been doing to make the entire collection workable, both with 2020 and 24. Not everything has been ported. If you go and take a look at what is there for part 9, here you see I've got the flight recorder working in C++, the list liveries we just looked at. I have list airports. And then, of course, there is list facilities, which has become quite large because it can also list NDBs, VORs, and waypoints, as well as airports. And if you list airports, then it will also tell you all the parkings at that airport. And that's becoming quite nice. I think I'll also make some kind of local repository to store that in. So rather than having to list everything, you can copy everything into that repository and then say, get me parking, and then a name for a parking at a certain airport, and it will give you the exact location for it. So what are we going to do from now? Well, We'll discuss the facilities in a little bit more detail. If you want to preview, take a look at demo 9.4. What I want to do before I record that is finish up that demo and also take a look at that repository that I've been discussing. So you can easily say, okay, now I want to create a Boeing 737 with KLM livery at this location, and you will get the correct title, correct livery name, and correct location in latitude, longitude, and altitude. So you can do the create AI, the non-ATC AI at that precise location. Next, we're going to look at client data, and I only have one add-on that uses that, which is the PMDG, or at least I've got two. I've got one on 2024. I've got the 737-800 now, a very nice airplane, and the 777-200. And we'll use that to demo the client data. And of course, I'll add in some C++ stuff to make that easy to use, because it's pretty basic as is. We already looked a little bit at it when we looked at sending events, and I'll integrate that into it. Then I'm not going to take a look at the insert string and retrieve string, which are a part of the API, but I think you shouldn't really use them. We should always use pointer safe stuff and not those void pointers. And yeah, so let's just stop doing C things and do nice C++ things. I haven't decided yet the weather API, and that's simply because I've never looked at it. I may look at it and do it. If you want me to take a look at it, please leave a comment. So that's it for this edition. Let me know what you think of it, and definitely take a look at the GitHub repository. You can follow there. There's a lot more happening, and you can see that if you look at it there. You can create issues if you think you found a bug, which are quite possibly there, or if you have suggestions to change something or add something, just let me know. And for the rest, if you feel like it, give me a like and a sub, and I'll see you next time.